This was supposed to be review, but I'm hearing that we're not quite ready to be doing this stuff on our own yet. And the person who told me that, I trust deeply, and they're really smart. So if they don't get it, I'm sure they're not alone. So we're going to start with this first practice question. And remember, you can always go to Khan Academy. There are a ton of videos out there to help you know how to do Punnett squares. You don't have to just listen to me. So anyway, what happens here, and I'm going to color code it because to me that makes more sense. And those of you who think that the sound is bad, there are headphones with a microphone attached on their way. I just don't have anything yet. And the noise you're hearing in the background is Hedman. So anyway, we're going to turn this into a pink capital W, and we're going to turn the little W's into little blue. Okay, this is a little W. And W's are hard, okay, because, you know, how do you know it's a big one or a little one? You have to be really careful when you write them down. So this big W is going to go into this square, and then it's also going to go into this square, because that's one of the two alleles that the male parent can give. And the big W, if it's there, it's dominant. And that big W, if it's there, is going to be expressed in the phenotype. So if there's a big W in the genotype, there's, for this case, white in the phenotype. So we got this big W that's coming from the dad and this big W that's coming from the dad, but the dad also has little W's to give. So little W, okay? That's coming from this parent right here. And this parent only has little W to give. So this parent has yellow wings, and this baby will get this W from the mom, and this W from the mom, and this W from the mom, and this W from the mom. Okay, so far so good. So when we fill in the genotype, that's going to be the alleles or the genes, and the genotypes, and I'm going to go back to the regular colored pen now. The genotypes are either big W, or little w, little w. That's the genotype. So what's the phenotype going to be? For this one, it's going to be white because it says white is dominant. For this one, it's going to be yellow because we have both of the recessive alleles. Both the recessive alleles are present. The chance, again, it's a chance because Punnett squares are probability. The chance of it being a white-winged butterfly is 50%, or 2 out of 4, or 1 out of 2, or 2, you know, a lot of ways to write it. We're just going to go with percent chance because that's what the worksheet is asking for. So there's a 50% chance it'll have yellow wings and a 50% chance it'll have white wings. The thing is, that's just a chance. They could have 100 babies and 97 of them have white wings. It's just a probability. Okay, back side of the paper. In dogs, there's a hereditary type of deafness caused by a recessive gene. 2 dogs who carry the gene for deafness, that means they're heterozygous. They carry the gene. That means that they don't have the trait because the dominant condition is not deafness or hearing or whatever. So they're using the letter D. I wouldn't have used the letter D. I probably would have used the letter H. H for hearing. But because hearing is the dominant trait. So this is caused by a recessive gene. The only way to have it is to have a little d, little d. So possible genotypes and phenotypes, I'm going to do the same thing. Turn the big D into a blue thing. Big D is going to be blue. Little d is going to be pink. Little d is pink. And then, you know, you guys, this is one of the things you're going to need to be able to do going forward. And, you know, if this isn't coming kind of like easily to you now, I need for you to, like I said, Khan Academy, practice some more. You know, if you Google Punnett square practice, there's a ton of stuff out there. But anyway, this D comes into this square from this parent. Okay, this is the allele that goes into this offspring and this offspring. Okay, from this parent, this little d, okay, from this parent to this offspring, this little d. Same thing here. This parent gives the capital D and the capital D, and then this parent only has, they have 2 genes to give. So this is the typical heterozygous cross. So the genotypes, again, let me get the regular pen, and I really wish you guys were in front of me. Maybe this would be better to Zoom, so you could say slow down or ask questions, or heaven forbid I make a mistake. But anyway, one genotype we could have is homozygous dominant, big D, big D. Another genotype we could have is heterozygous. Heterozygous means the dominant trait will be expressed in the phenotype because that capital letter is there. That big letter's there in complete dominance, or in Mendelian genetics. This is how it's going to work out every time. But like I said, next week we're going to be learning the next thing. So this is like the addition part. You guys got to get the addition down and the subtraction, because next week we're multiplying and dividing. Okay, so you got to let me know. You got to pause. The person who let me know this morning, wait, I don't get it. That's what I need from you, because I'm just assuming you guys are getting it. Okay, so big D, that's the genotype, that's the alleles, that's the genes. All of those things are the same. That's the letters. Phenotype is the physical expression, and you should know that it's caused by a recessive gene. This dog is big D. He can hear, okay, or she. Big D, little d, the big D's there. The dominant trait will be expressed in the phenotype. This is a hearing animal, and this one is deaf. Okay, what are the chances of the offspring having this? Well, it's going to be 1 out of 4, or 25%. Again, percent chance. You will see it sometimes written. You will see it sometimes written as 1 out of 4. Sometimes you'll see it as 2 out of 4, 1, 2, or 50%. And this little d guy that's deaf, it's a 25% chance. But that word chance is really important. It's a probability. They could have 8 babies and 4 of them be deaf. I mean, it's just a probability. Chances are not likely. Oh my goodness, Hedman has just found the doorstop thingy. Hey, Heads. The next one. Let me make sure I got this centered properly. In guinea pigs, short hair is dominant over long hair. If a short-haired guinea pig is crossed with a long-haired guinea pig, and this is a dominant, it's homozygous dominant, and this guy is homozygous recessive. What are the possible phenotypes and genotypes of their offspring and the percent chance of each? Okay, again, let's do this like this. This is going to be a big S, okay? And the pink, oh, this is a big S too. See, S's are hard too. S's, C's, L's, W's, any letters that look similar. P's are awful, and P's are common. And then this is a little s. So this is the mom. The mom's going to put an S, little s in each one of these squares, right? And the convention is we write the capital letter first. So, the dad's given one of these in each square. Oops. Okay. The genotypes. Well, we've got one genotype. I think they did this like this to confuse you. All of the offspring are this. The phenotype is short hair. And the chance is 100%. Unless there's a mutation. That's all you're going to get. Okay, here's our more practice. 9 minutes. Okay, I'm posting it. Bye.